right, let's talk about Newton's laws of motion. So, first off, what is Newton's first law of motion? Well, what we find is an object at rest will stay at rest if there's no forces acting on it, and an object in motion will stay in motion with a constant velocity if there's no forces acting on it. You've probably heard of this in junior high. Object at rest will stay at rest, and object in motion will stay in motion. How will a moving object move if there's no forces acting on it? Now, we're pretty comfortable with the fact that if this object's at rest, will stay at rest. But an object that's moving, what will it do if no forces are acting on it? Like if you throw a baseball in outer space, deep outer space, what's going to happen to it? Well, it's going to keep on moving at a constant speed in a straight line path for like ever, unless another force acts on it, which is a crazy thought. So, how will an object move if unbalanced forces are acting on it? So, if a force acts on it, well, it won't continue to move at a constant velocity. So, that probably means something, the velocity is going to change. So, a little foreshadowing there. Inertia, what is that? It is an object's natural tendency to maintain its present state of motion. So, what does an object's inertia want to do if it's at rest? Well, the inertia wants to do whatever it's doing. Its present state of motion is at rest, so it wants to stay at rest. What does an object inertia want to do if it's moving? Well, it wants to maintain its present motion, which means to continue moving, whatever speed it has, and in whatever direction it's moving. Like that's what it wants to do. It's like its natural tendency to keep on doing whatever it's doing. So, how much inertia an object has is dependent upon what measurement. What would give something a lot of inertia? Mass. It is solely dependent upon mass. So, what is mass? Well, it's the amount of substance or material of an object. It's kind of based upon how much subatomic particles, how much protons and neutrons primarily make up an object, but we're not going to go that detailed. Variable for mass is lowercase m. The SI unit for mass is in physics, it's actually kilograms. In chemistry, you use grams. In physics, we use kilograms. So, what is the variable for force? It is a capital F. The equation for Newton's second law of motion. So, Newton's first law of motion was kind of a statement. Newton's second law of motion is an equation. It's force is equal to mass times acceleration. So that's probably like one of the most famous. If you talk to anybody who's taken physics, like what's the most useful equation? They're going to say F equals ma. So how would we describe that in words? Well, to do that, we're going to rearrange that mathematically, and we're going to divide by m. So you have force over mass is equal to acceleration. Why should we do that? Well, that puts us to a proportion. So acceleration is directly proportional to the force, inversely proportional to the mass. So as the force gets bigger, acceleration gets bigger. As mass gets bigger, acceleration gets smaller. The unit for force and its abbreviation is a Newton, as in Isaac Newton or Big Newton, and the abbreviation for that is a capital N. The units, where did that come from? Where does a Newton come from? Well, we're going to look at the equation. So force is equal to mass times acceleration. What is the unit for mass? We have a kilogram, and the unit for acceleration is meters per second squared. So, and that is what a Newton is equal to is a kilogram times a meter per second squared. It's kind of like, so kilogram and meters and seconds, they're kind of like the primary colors for units, and you can mix and match them to come up with stuff. So that's what you get for a Newton. The force is a force, a vector or scalar measurement. Does it have direction? it does have direction, so it is a vector. Is mass a vector or scalar measurement? Mass doesn't really have direction, so it is a scalar measurement. So, how does the direction of force acting on an object compare to the direction of acceleration of an object caused by that force? Well, if we look at Newton's second law, this mass doesn't have direction. Force has direction, it's a vector, so whatever the direction of force is, that is the exact same direction as acceleration. Um, so force determines the direction of acceleration. So is acceleration a scalar or vector quantity measurement? Well, we kind of just alluded to that, the fact that it has direction from the previous slide, so therefore it is a vector. So in terms of the motion of an object, what are the two things that are that the direction of acceleration depends on? So previous slide we looked at force. This is looking at motion. So there's two different ways to figure out the direction of acceleration. This second way is looking at the motion. So the first thing you have to look at is the direction of motion, specifically the direction of velocity, and whether the object is speeding up or slowing down. Now, the general principle for determining the direction of acceleration in regard to motion, here it is big. If an object is speeding up, then the acceleration has the same direction as velocity. And if an object is slowing down, then the acceleration has the opposite direction of velocity. This is kind of a big slide right here. We'll touch on that a lot. It's next lesson. So, describe both ways you can have a positive acceleration. Both ways. Both ways. Well, first way is most people can get this one. If an object is moving in a positive direction and it is speeding up, has a positive acceleration. But there's a second way you can have positive acceleration, and that is if you are moving in the negative direction and slowing down. Okay? So if you're slowing down then and moving in the negative direction, then acceleration is going to have the opposite sign of velocity, which is positive. A little crazy. Here's the takeaway here. Do not associate positive acceleration with speeding up. That is true half of the time. So bad thing to associate. What are two ways you can have a negative acceleration? First way is more obvious. If you're moving in the positive direction and you're slowing down, most people are like, yeah, that makes sense. But you can also get that by saying if an object is moving in the negative direction and it is speeding up. Okay, so if you are speeding up in the negative direction, then that means that acceleration has to have the same sign as velocity, which would be negative. So do not associate, that should be a negative acceleration with slowing down.